So let us see the factor affect the capacitance of the capacitor. So there are the three factors that affect the capacitance of capacitor. So the first factor that affect the capacitance of the capacitor, that is the area of the plates, that is denoted by A. That is the first factor. So if we increase the area of the plate, area of plates increased, so the amount of charges in these plates will also increase. So amount of charge increase when we increase the area of the plate. Here is also amount of charge increase when we increase the area of the plate. So we can say that the capacitance of capacitor increase when we increase the area of plates. Now the second factor that affect the capacitance of the capacitor, that is the distance between two plates. If we decrease the distance between the two plates is reduced, then the amount of charges increase. So when the distance between two plates decrease, the amount of charges that can be stored across the capacitor will also increase. Third factor that affect the capacitance of the capacitors, that is the dielectric medium. The dielectric medium between the two plates, dielectric medium between these two plates will also increase capacitance. So dielectric medium also increase the capacitance of capacitor. So formula of the capacitance of the capacitor is C is equal to A into epsilon naught upon distance D, where A is the area of plates, epsilon naught is permittivity of the medium, D is the distance between plates. For vacuum, the capacitance of the capacitance we can write A epsilon naught over D, and for medium, the capacitance of the capacitors is A epsilon naught upon D. So by using these two formula, we can write C capacitance of the medium in the presence of the dielectric is equal to epsilon R capacitance of the medium in the presence of vacuum. So we can write capacitance of the medium is greater than capacitance of the vacuum. Effect of dielectric in capacitance. When we put dielectric between the two plates of capacitor, capacitance will increase. We can it denoted by the formula, that is capacitance in the presence of the medium is equal to epsilon R time C in the presence of vacuum. So we can, this formula is epsilon R is equal to C medium to C vacuum. This is known as epsilon R is the relative permittivity. What is relative permittivity? Relative permittivity, epsilon R is the ratio of capacitance in the presence of medium to capacitance in the absence of medium. We can also say that epsilon R is equal to 1 for vacuum and epsilon R is greater than 1 for medium. Now here the question is arise, how capacitance increase by dielectric medium. This phenomena can be explained by electric polarization. Now, what is the electric polarization? Electric polarization is basically the redistribution of charges inside the dielectric, or we can define the rearrangement of dipoles of dielectric in the presence of electric field. When we put the unpolarized dielectric medium between the plates, then the dipole of the dielectric rearrange themselves in the presence of electric field of these charges of the plate of the capacitor. Here, the negative charges attract by the positive plate, and here positive charges attract by the negative plate. So dipoles rearrange themselves by electrostatic repulsion or electrostatic attraction between the plates of the capacitor. So rearrangement of the dipole is reduce the electric field. When electric field is reduced, so potential is reduced. When potential is reduced, then charges on the capacitor will increase. When charges increase, so capacitance of the capacitor will also increase.